Hello class, it's Mr. Cowboy here again, and I'm here to present the next shape, which is going to be dealing with a cylinder. And we're going to just deal with the one shape for today, but however, we will be looking at both surface area and volume for the cylinder here. All right, so before we begin, just take a look at your formula sheet here again. If you don't have it, just grab it somewhere. All right, and what I want you to see here again is where to find it on your formula sheet. So if you take a look at your formula sheet here, we're looking at the top shape here, as you can see, and the two formulas that are that you see here. All right. Now, when we're dealing with a cylinder, what we have to see here again, we're only dealing with one shape, and it's a very familiar shape because it's an everyday item that I'm sure you see on a regular basis here. All right. So when we're talking about cylinders, okay, and the most basic example of a cylinder again is a can here. For some reason, that's not showing up, and it's showing up as something that's see-through. All right. So as you can see, this is an example of a cylinder. Now, what you have to see when we're discussing a cylinder here is that when we're dealing, especially when it comes to surface area, okay, there's something that you have to see when it comes to the formula for the surface area of a cylinder, especially when it comes to the shapes there. All right, so just have your formula sheet here handy as we go through these examples here. All right, so let's jump to it over here. So when we're dealing with cylinders, the main thing you have to see here again is that it is actually comprised of, when it comes to surface area, that is, it's actually made up of two different parts here. Now, when we're looking at the surface area, okay, when you're looking at the formula here, what we have here is the surface area is 2 pi r squared plus 2 pi r h. Now, you do need to understand what the two parts represent when we're dealing with the surface area of a cylinder. So the first part you have to see here is that a cylinder is actually made up of three faces in particular. And the faces that are quite obvious here are the two circular faces, that tend to represent the top and the bottom of, let's say, a can, okay, such as this one over here that for some reason is showing up invisible. Ah, there it is. All right, so that would be an example of the two bottom faces there. So that would be the first bottom face, okay, and then the second bottom face. So that's why what we have there are two circular ends. So I represent that in the pink. I think it's easier to see it that way. All right. Now, the formula, when it comes to the two circular ends, okay, is actually represented by the 2 pi r squared part. Okay, so if you take a look at the formula here, remember that pi r squared is the area of one circle. So since we have two, that's why there's a 2 that's in front there. All right. Now the curved part, and if you want to think about what this is that if you buy, for example, a canned good, okay, it's the label that's around it. Okay, that would be the curved side. Now the curved side in the formula is defined by 2 pi r h. Okay, so just know those two different parts here. So again, you understand exactly what surface area is for a cylinder. All right, now what the volume is given, it's given by the formula, okay, pi r squared h. Now what pi r squared is again, okay, it's the area of the circular part, okay, and since it's the area of the base, in this case here, a cylinder is a circular base. When you multiply it by the height, that's what gives us a formula. All right. Now keep in mind that what you have here for units are exactly the same thing as we have seen for both surface area and volume. So for surface area, it's always going to be square units, and for volume, it's always going to be cubic units. Now, if you take a look at the diagram here, you notice the two letters we have here are radius and height. However, sometimes we have to be careful when it comes to the radius here, because sometimes you'll be given information such that what you have here is the entire distance across. So the radius, as you can see here, is the distance from the center of the circular face, okay, to the edge of it. So remember that you have the total distance across. This is what's called the diameter. So if you have a radius and you want to get the diameter, all you would need to do is take the radius there and multiply it by 2. Okay? In an opposite fashion, if you were given the diameter, you would have to take the diameter and divide it by 2 to get the radius. Okay? So as we go through these questions here, just keep all that in mind when we're taking a look at these examples. All right, so let's take a look at some numerical examples. And the first thing we're going to do here is to calculate the surface area of a can. Okay, nice simple calculation first. Now you notice that what we have here is exactly what we need. Okay, so the 1.25 here would be the radius, and the height here would be the 3.5. Okay, and when you carefully put this in your calculator, including the pi sign, by the way, use the pi sign in your calculator, you should get approximately 37.30 square inches. Okay, so remember it's square inches in this case here because what we have here is the surface area. All right. So that's the calculation of the surface area. So let's take a look at the calculation for volume. So exactly same thing, pi r squared h. Okay, we take the r, replace it in for with 1.25, and the height, replace it with 3.5. Just be careful with this one here because you notice the 1.25 is squared. So make sure you press that x squared key after you put the 1.25 in brackets. Okay, and you should get there 17.2 cubic inches. All right. So again, we start off with this the units for inches, and it's cubed for this one here because we are dealing with volume. All right. Okay, so next one here, let's now take a look at, again, same type of problems. Now you notice we don't have a diagram for this one, so we need to be aware in terms of what information is given to us in the word problem here. So it says calculate the surface area and volume of a cylinder that has a diameter of 36 inches and a height of 24 inches. Now carefully again, just read that question again. All right, now by taking a look at the formulas, you notice for the formulas, the variables that we have here are r for radius and h for height. Okay, and if you take a look at the word problem, notice that we don't have a radius. However, there is a way we can figure that out. So remember there was a relationship between diameter and radius. So remember the diameter is the total distance across of the circular face, and whereas the radius is the distance from the middle to the end of it. So to find the radius over here, we have to take the diameter, okay, and divide it by 2. So we take that 36 divided by 2. So that gives us here a radius of 18 inches. All right, and that's pretty much it. It's the only additional step. Okay, so from here, that would be the radius r here. Okay, and the height here will be 24. So when we put that into the formula for surface area, okay, you should get 4,750.09 square inches approximately. All right. And as you can see with the volume, we're just going to put the numbers in accordingly, and you will get 24,429.03 cubic inches. All right. All right, so we've seen some pretty basic examples here. So let's just take a look at a quick word problem here. And what we're going to do here is we're going to look at a cylinder inside a cylinder. So what this question actually involves here is just for us to see what we need to do or what steps we need to take here to find out the volume of an object once it's hollowed out. So what we have here is the pattern around the support post of a mesh enclosure of a trampoline is in the shape of a cylinder that has been hollowed out by removing a smaller cylinder. And what we have here is that both of them have the same height of 6 feet. And what we have here is that the piece on the outside, or the outer part here, has a radius of 4 inches, okay? And the smaller part here has an inner radius of 2 inches. And what we want to do here is to calculate the volume of one piece of foam padding after it's been hollowed out. Now, before we do that, just take a look at the diagram and just the diagram. And I want you to notice there's something a little bit peculiar about this question here, all right? Notice the radius here are both given in inches. However, the height is in feet. Now, our final answer needs to be in cubic inches. So what we have to do first here before we actually start looking at the volumes is we actually need to do conversion because everything has to be the same unit. So since we want everything in cubic inches, the first thing we need to do is to convert the 6 feet. Okay, and if you have your conversion chart there handy, okay, you'll probably see there in order to go from feet to inches, okay, we have to multiply the number of feet there by 12. Okay, that's just to make everything the same unit here. So when we do that, that 6 foot part there is now going to be 72 inches. Okay, so just make sure you label that accordingly. Now that all the units here are the same, now what we need to do here is to solve and think of a plan on how to solve this. Now, what we want to do here is that we actually have, again, we have to think about this. We have two shapes where one is inside of the other there. Now, since we're hollowing something out, okay, we have to take the volumes of the two shapes, and since we're hollowing out one shape from the other, once we find the two volumes, we need to subtract them from each other, okay, because we're taking one piece out, and that's exactly how we're going to approach this question. So step number one here, we need to find the volume of the outer cylinder first, okay, using the formula pi r squared h. Okay, so starting with the radius, okay, the outer part again is the quote the bigger tube. So the radius there would be 4. Okay, and the height will be 72, and actually the height will be the same for both of them. Okay, and we put those numbers in here. Okay, we get 3,619.11 cubic inches. All right, so that's step number one. Okay, step number two. Okay, we're now going to find the volume of the smaller tube or the thinner tube, which is inside. And again, for this one here, the only difference is the radius here is the 2. However, the height here is the same, okay? And then from here, when you put the numbers in, we wind up getting that. Now remember that the inner cylinder, which is the inside, is now going to be removed. So we're going to do exactly that. We're going to remove it from the outer cylinder. So the volume of the tube itself is going to be 2,714.33 cubic inches. All right. So again, when you're dealing with the objects and you're trying to figure out, again, the steps that is required, okay, what we have just done here, believe it or not, you can do for any two shapes that you see. And you're going to see in another lesson, we're going to see a very similar example as this, just dealing with different shapes here. All right. Okay, so the last thing we're now going to do, as you can see, all we've done so far is we've solved for the surface area or volume of the cylinder. In this question here, we'll be solving for something else. So we're actually going to do a little bit more algebra in order for us to do this here. And in this case over here, we're solving for a specific measurement or specific dimension. Okay, so it says a company that manufactures fruit juice needs to make a new cylindrical container that can hold a volume of 4,000 cubic meters of fruit juice. Okay, it says if the tank has a height of 25 meters, okay, we want to figure out the radius. Now, take a moment to read the question again, because you notice in this question, it doesn't tell you to solve for a volume, nor does it tell you to solve for a surface area. So what we have to do for this question here is to read the question, see what information is given to you, because writing down the correct formula in the first step is very, very crucial for us to get the correct answer here, all right? Now, if you read the question very carefully, always take a look at what the units are for anything that involves a number. And the reason why I'm pointing that out here, because if you look at the very first paragraph, okay, a volume is given to us. So since a volume is given to us, the first thing we need to do here is understand that we need to use the volume formula in order for us to solve this problem. So if there's a piece of information that's given to you, okay, use the units to determine what formula that will be. Okay, so since, as I mentioned earlier, okay, since we have a volume measurement in the question, we're going to write down the formula volume for volume of a cylinder in order for us to answer this question here, all right? Now, the next thing we want to do here is to see what information that we have and see what we don't have. So starting off with the 4,000 cubic meters, that's going to be the volume. So that's going to replace the V. So I'm going to highlight that in pink. And the height here is going to be 25 meters. So that's going to replace the H here, okay? So notice what I've highlighted there are the letters that we're going to substitute in with those numbers. So we're going to do that in the next step, okay? Now, the next step that I'm going to do from here is just to clean it up here, because it just looks a little bit, it just looks a little bit confusing right now. So all I'm going to do is I'm just going to take the right side here and just clean it up a bit. I'm just going to rewrite it here. Okay, and the way I'm going to do that is I'm going to take the 25, okay, and the pi and just group them together, okay, like this. All right, I haven't changed a thing, by the way. Now, keep in mind that pi is a number, and we're going to keep it exactly like that, because I want you to see we're actually going to do the next step using exactly what you see in the screen there. As you can see, what we have to solve for here is the radius. Okay, and you notice there's a tiny 2 attached to it, and we're going to deal with that in the final step here. So what we're going to do here in the next step here is to just make a note of the fact that we do need to leave the r squared term first. Okay, so we're not going to do anything with the squared just yet. So what we need to do here is understand that the 25, the pi, and the r squared are grouped together by multiplication. So our next step here is to perform the opposite of that, which is division. And the way we do that is to isolate the r squared part is we actually need to divide both sides by 25 pi. Now, the reason why, and I want you to make a note in terms of what cancels out on the right side, is that when we divide both sides here by 25 pi, the 25 pi's on the right side cancel out, and as you can see, we now have the r squared on its own on the right side. And then 4,000 divided by 25 pi, that's going to give me this number over here, okay? Now make sure that in the steps in between, you keep it to as many decimal places as possible. I tend to tell people just to keep it to 4 or 5. You don't need to go overboard, okay? But at the same token, don't just leave it as 1, okay? And as you can see for the final step, now we just take the square root of both sides, and we now have a radius of 7.1 meters, okay? So notice that in this question here, the volume was given to us and we had to solve for something else, okay? So that's why it's very important that you see when you read a question very similar to this, You see what units there are based on the information provided, and then from there, pick the formula. All right. All right, last but not least here, since we have the radius, we just want to figure out very quickly what the diameter is. Now, in the previous two examples ago, we had the diameter and we had to find the radius by dividing by 2. Okay, on the opposite end, we want to find the diameter from the radius, and all we're going to do to that is take the radius and multiply it by 2. So the diameter for this particular object here will be 14.2 meters. All right. Okay, so that wraps up another segment here for chapter 9 here. Okay, so continue on working with your review, and I'll see you in the next lesson.